All right, in this video, we're going to be solving proportions. So there's going to be word problems, there's going to be graphs and pictures. We're going to be solving all different types of proportions. Each proportion will be set up as two equal ratios, and we really want to think about what is the word ratio, what is being described by each ratio, and they should be consistent. If I say this is miles and this is gallons, this also needs to represent the exact same thing in the same order. Miles on top, gallons on the bottom. So in my first question, there are 12 boys and 14 girls. 12 boys, 14 girls in your English class. If the same ratio exists in the whole school, basically that's saying that it will be proportion. The same ratio, equal ratios exist. About how many girls are there out of the 1,086 students at Liberty? Be careful here. That is talking about all of our students. This is talking about boys and girls separately. The question will really drive your word ratio. I'm talking about how many girls. That's my question. So I don't know the number of girls out of the total number of students, all of my students. So girls is 14 out of how many total students do I have in my English class? It's not going to be 12. That's just representing boys. I'm going to put those two together. And that gives me 26. And the question's asking about how many girls out of the total population. We don't know the number of girls, but we know the total population. That's 1,086. So my next step is to cross multiply. Once I have my proportion set up, I want to solve for this by cross multiplying 14 times 1,086. That's 15,020. Oh no, sorry, 15,204. And then I cross multiply the other two, 26 times x, and put that on the opposite side of the equal sign, 26x on that side. So I have one more step. I'm going to divide by 26 on both sides. And that tells me that x is 584.77. I'm just going to round that. We're talking about people, and the question is about how many. So I want to think about how many is that. I'm going to round that to the appropriate number. That's 585 girls. On the second one, we are talking about a cookie recipe that calls for 1.5 cups of chocolate chips to make 24 cookies. So it seems like I'm comparing chocolate chips and cookies at first. How many cups of chocolate chips would it take to make 110 cookies? That's exactly what I'm comparing. I'm going to abbreviate that as chocolate chips compared to cookies. That is my word ratio. That will generate everything that I set up in the proportion. It's 1.5 cups, 1.5 cups. To change this into a decimal, 1/2 is 0.5. You really just add those two together. It's 1 plus that 0.5, so that's 1.5, 1.5. That makes 24 cookies. We don't know the number of cups of chocolate chips that it takes to make 110 cookies. So now we'll cross multiply 1.5 times 110, that's 175. Sorry, no, that's 165. And then we'll cross multiply 24 times x, that is just 24x. The last step is to divide by that 24, and that gives us that x equals 6.875. And that is representing cups. I do want you to label that with the units, 6.875 cups. If you want to write that as a fraction, it's 6 7/8. It's more likely in a recipe that you would see a fraction, but for this purpose, we can write that as a decimal. All right, our next two word problems will both deal with percentages. So this one says that our last test had 30 questions. If you got 80% of the questions correct, how many questions did you get correct? So this is not like the first two where you were given 3 numbers and you had to find the 4th one, or here you actually even needed to think about the total number of students. Here we're just given 2 numbers. So it seems like it might not be enough, but this percentage means something very specific. A percent means out of 100. So this number is actually 80% out of 100. Actually, I'm going to drop the percent sign. Once we put it as a fraction, it's no longer really a percent. These are equivalent. 80% and 80 out of 100 are really the exact same thing. This percentage will drive the entire proportion. The rest of this is set up based off of that percentage. So this 80% is talking about how many I get correct. The bottom of this is always talking about the total. The bottom of a percentage in a proportion is always 100%, and it's always talking about the total because 100% does represent the total percentage. So we got 80% out of 100, and we know that 30 questions is not the number that we got correct, it's our total number of questions. We don't know how many we got correct. From there, we're going to cross multiply. That's going to give us 2,400 equals 100 times x. Again, the order actually here doesn't matter. If you wanted to write this as 100x equals 2,400, you're going to cross multiply each of these pairs and put them on either side of that equal sign. And the final step is dividing by 100 on both sides. That gives us that x is 24. Make sure that this makes sense. If you got a number bigger than 30, that doesn't really make sense. There's 30 questions on the whole test. You can't get more questions correct than there are. That is the number of questions that we got correct. 24 out of 30. All right, on this fourth one, the library has a total of 6,075 books. If there are 2,225 books checked out, what percent of the books are not checked out? We really need to read this one carefully. What percentage of the books are not checked out? Okay, so all of these are taken out of the total. So before I even set up the proportion, I really want to think about the question. What's the question asking? How many are not checked out? So I need to figure out that number first, not a percent yet. Eventually I'll get to what percent of the books, but first I need to figure out actually how many books is that. So I'm going to subtract those two. That's my total. These are the ones that are checked out. Then I have 3,850 left over. Those are the ones that are not checked out. And you might think we're done because that's kind of what we're looking for, but we're looking for a percentage. Now remember from over here, the percent always goes over 100. If we don't know the percentage yet, that's what the question's asking for. That is our unknown amount. That's going to be our x. We don't know the percent yet. We don't know the number that goes over 100, but we know that it's going to represent the ones that are not checked out over our total. These are not checked out. That's going to be a percentage that are not checked out of the total percentage, which is 100. On the other side of the proportion, we have the ones that are not checked out over our total. And from there, it's just solving that proportion by cross multiplying. 6,075 x equals 385,000. And one more step, we're going to divide by this 6,075. It'll cancel out on that side and give us that x equals, when you divide this by 6,075, you get 63.37. And it's not like this one where we're asked a number of people. This is a percentage. We're allowed to round that to a decimal, so I'm going to keep that as 63.37%. All right, another way that we can be asked these questions is from a picture or from a graph. So instead of being given all the information that we need in the word problem, this pie chart offers a lot of information. Actually, a pie chart is a dead giveaway for percentages. It's telling us that we will set up our proportion as a percent over 100. So let's read the context here. David polled people at the mall to determine what type of movies they preferred to watch. Answer each question using the diagram on the left. Of the people polled, of all of the people, 210 preferred to watch comedies. What's the total number of people polled? So we're talking about 210 watching comedies. That is that group. That is represented by 35% out of 100. There are 210 people in this block. 210 out of some total number of people. All right, so I'm going to have you cross multiply and finish that problem. But that setup is generated by the percent over 100, the percent over 100, and then think about what this means. That's comedy out of total, so this also needs to be comedy out of total. The second question, we're going to treat this as a whole new question. We're basically ignoring this total that we just found. If a total of 1,500 people were polled, that's our total. So again, I already know I'm going to use a percent because this pie chart represents percent out of 100. So I know this is my total. I'm going to start by putting that on the bottom. How many people prefer to watch horror movies? So horror is represented by this 5%. 5% out of 100 equals some number out of 1,500. And you notice I switched the sides. This, I had the percentage on this side of the proportion. Here I have the percent on this side of the proportion. Doesn't really change anything. It's the exact same thing. Proportions, really equations, can be flip-flopped. I can rewrite this as 5 out of 100 and x out of 1,500. If that makes you more comfortable, write it like that, where you have the percent over 100 on this side each time. That's fine. But you should recognize that it really doesn't matter. An equal sign can be flip-flopped like that. So again, I'm going to have you finish this problem. I think by now we've done enough cross multiplication where you should be able to finish that and solve for that x. All right, now this is a bar graph. We're going to use that bar graph to answer the questions below about the favorite pets in Mr. Nussbaum's class. So we can see that 3 people picked dog. Not sure how that's not more, but 4 people picked cat. 2 people picked fish, and there's the 1 hamster person. So what percent? That is telling me right away I'm going to use a percent out of 100, and I don't know the percent. That's really important. What is the percent? I don't know the percent, but I know it's going to be out of 100. That is how I write a percent each time. This is going to drive my whole proportion. What percent of students said that a dog or a cat was their favorite? So there are no numbers in this question at all, but everything is coming from here. So I'm thinking about what percent is that really representing? That's talking about the percent of people who chose dog or cat. That's these two groups together. That's 7. Compared to the total number of people, that's all the bars added up, that's 10. Hopefully you might even be able to see what that percentage is right away, but if not, cross multiply and finish that one to solve for that percentage. On letter B, the whole school was surveyed and the proportions remain the same. So compared to this class, the entire school, really it should say the ratios remain the same, but the proportion is intact. It's an equal proportion between this class and the whole school. If there are 500 people in the school, that's a total number of people in the school. How many people did not say hamster? So I'm going to say that's not hamster. So out of 500 people, I don't know what that number is. I didn't survey all 500 people, but in this group of 10 people, I know that these 9 did not pick hamster. So it's 9 out of 10 that did not pick hamster versus some number out of 500 that did not pick hamster. Again, I'm going to expect you to finish that one on your own. All right, last question. We have this map, and the map represents Northern America. 2.5 inches on the map represents 150 miles in actual distance. So there, I'm comparing inches to miles. It's not always going to work out that simply, that you just set up your word ratio that way. So I really need to read the question and make sure that these 2 units are still consistent in the question part. If Green Bay is 3.5 3¼ inches away from Chicago on the map. So it's talking about from there to there. If that's 3¼ inches, how far away are the two cities in miles? So actually that ratio is true for that question. It's talking about inches compared to miles. 2.5 inches represents 150 miles. How many miles does 3¼ inches represent? We don't know the number of miles that matches up with that, but we know that inches are represented on top and miles are represented on the bottom. We need to find that number of miles. All right, so you should be able to complete those on your own, as well as the additional questions at the end of this video. If you do need any help, please let me know.